Hello. This is going to be the first project that we're going to do with the Click PLC. It's the 110 version, input, relay, output, 3-COM port with the RS-485 included, not just the two 232 ports. This is a mock-up panel for me to do a lot of these projects, so it's not arranged for permanent fixture panel type stuff. This is just so I can configure different lights as outputs and different push buttons configured NO or NC for inputs. This particular one that we're going to be doing is kind of modeled off of an idea I had after working on an abrasive blast machine that's got some really old control. Don't get me wrong, when it was commissioned it was probably the most current thing out there, but nowadays... Okay, sorry about that. We had some full memory on this camera. Anyway, the control system on the machine that I kind of got this idea to do this for is pretty outdated. It causes some problems, and I kind of want to go through what some of these things are, what this machine does without having to draw a picture. It's an abrasive blast machine. It's a wheel type blaster where it has wheels turning, casting, throwing shot or abrasive blast media down on the workpiece very, very fast, and this abrades mill scale and rust off of metal. The wheels are powered by motors. The wheels are directly coupled to the motor shafts in every instance I've ever seen. And here, these lights are going to represent outputs of 3 motors. These machines create a lot of dust, airborne fines and particulates, so there's always an air handler with a baghouse filtration type system, and this light is the output for it. This light represents the recycle system, which can generally be several motor starters controlling motors that by mechanical means, after the shot or abrasive blast media has hit the workpiece and fallen to the bottom of the machine via gravity, the recycle system with augers and conveyors and elevators mechanically moves the abrasive blast material back up to a hopper on the top of the machine, where it can then fall with gravity through a tube back down to the wheel or the motors to be cast back down onto the workpiece. If this doesn't run, you throw all of your media down and it never goes back up. That creates a problem. It's kind of like a recirc pump. This particular machine setup is really similar to some other stuff I've worked on, namely maybe glass edgers that have motors that are polishing down the edges of glass. They come on, but they can't come on until a coolant recycle comes on to make sure the coolant's running before the motors start edging the glass. This is kind of a pretty simple control, because what we want is we want the air handler on, then we want the recycle on, then we want the motors on, but the motors are 25 or 30 horse a piece. In my particular instance, you can't turn them all on at once. Some of the machines have 8 motors. I'm only using 3 because I'm limited on my outputs for this PLC. So if I had a module, I'd make more motors, if I had an output module. We got to turn these on one at a time, because we don't want those startup amps happening all at once, or we're going to blow fuses. It's going to be messy. That's just too much draw. So we want things to come on one at a time. We want the air handler to come on. We want the recycle to come on, so it's ready to recycle the shot material. Then we want our motors to come on. Don't pay attention to this fault light right here. This fault light later on will be tied mechanically to a sensor flag on the recycle. If the recycle ever stops because the mechanical drive, gearbox goes out, belts slip, whatever, and we stop having some shaft rotation on these mechanical components in the recycle, we want to turn off the motors so they don't cast any more of the abrasive material down and trip a fault light. We don't have that. I don't have that set up yet. I've got to make a jig because I want to actually mimic that physical switch or sensor making at a certain frequency and kind of test that. Down here we have a start, and that's going to kind of auto start the whole system in a timed, orderly fashion. We have a stop, and this is an all stop. It doesn't replace an e-stop necessarily, but it's going to stop everything all at once, no order whatsoever. This is a way to turn on your air handler manually. This is a way to turn on your recycle manually. Those are important because a guy can be cleaning up his machine. If any material has gotten onto the floor and he needs to put it back in the machine, he doesn't have to climb up on top of it and put it in the hopper. He can run the recycle and just sweep or blow the abrasive material back to the machine where it will be recycled back up to a top hopper. While he's doing that, he may want to be breathing some clean air, so he can turn this air handler on manually. He can stop him with the stop button. He can stop the entire cycle after he hits start with the stop button. He cannot turn on the wheels, the motors, manually. We want control of that. We want to put conditions in before those motors will come on, namely air handler and abrasive recycle. So that's what this start button does. It takes the order and fashion that things happen out of the control of the operator, so he just starts it or stops it. Don't pay attention to this toggle for auto, off, manual. This is kind of a setup for some other different things that I've been doing. It doesn't apply to this. This stop button that I have not labeled, yes, I haven't labeled, is kind of an organized shutdown, organized stop. This is when he wants to finish his blast session. He can hit this button. And unlike this one shuts everything all off at once. This one will actually cut things off in an orderly fashion to prevent any jam-ups. What it will do is, first it will shut off the abrasive blast wheels. It'll stop throwing the abrasive material. It will wait for a little while. Then it will turn off the recycle. After it feels that the recycle system has caught up with whatever was in the bottom of the machine, then it will turn off the air handler, at which point everything is reset and he could restart if he wanted or walk away. The cool thing that I've got going on with this logic is, even if he presses the organized shutdown button, for some reason he hears a belt squealing, something's not right, he can hit that stop button right there, and it's not gonna wait for all that whole timed shutdown. It's just gonna shut it down right then. But if he's just stopping his blast session, this is a better one. He can just hit that and know that the wheels will shut off, the motors will shut off a little bit later, and we can change values on this, is the great thing. A little bit later, recycle will shut off, and a few seconds later your air handler will shut off. It's pretty cool. I like it. Once I get the recycle fault sensor going, it's really going to be pretty neat. I don't know if I'll be able to show you the ladder logic on this video. I'm going to have to figure out how to take screenshots and insert them. I find it intuitive. This has been my first PLC program. I've not really received formal training for PLC programming. I'm just a maintenance guy. I've worked with ladder logic a lot before, and I'm taking the opportunity. I bought a Click PLC, did a lot of learning, did a lot of messing around, built this little trainer panel, and now anything that comes to mind, I'm kind of designing control to see if it fixes it. Not that it'll ever be used where I work at, I don't know, but they're ideas, and you got to foster your ideas to make things better. That's the point. I want to use all the instruction list and then start looking at, you know, data and math and analog and all the other good stuff involved with this, and just do it. Just make examples, control examples, based on things I've worked on. So we're going to go ahead and fire this up. Okay, I hope the light's all right. Okay, I'm going to hit the start button. When I hit the start button, we all see air handler come on right away, and then we ought to see recycle, and then we ought to see wheels or motors come on one at a time. So air handler comes on a few seconds later, recycle comes on a few seconds later, motor 1, and so on. Okay, and there's your timed orderly fashion. Make sure that that recycle and that air handler is on before the machine starts doing its messy business. They're safeguards to protect the machine, to protect the operator. We're doing this all, you know, timers that would normally cost, you know, bottom of the line timers probably cost $35 a piece for on delay electromechanical timers. You know, we're doing this with a $100 PLC, and so far, you know, look at how many timers we're using. This is a drum instruction that I'm actually using to do this. It's pretty neat. It's kind of one of the more advanced instructions with the click, but I found it pretty easy to use. The software was really intuitive. I'm not trying to plug Koyo or Automation Direct, although they have good stuff. Okay, I can hit the stop button, and it's going to kick everything off all at once. Okay, so turn it back on. If I need to stop it in the middle of this, I can stop it. I don't have to let it all come on. Okay, I can also turn on air handler and recycle manually. That's good. You want that for you know, operator to utilize certain functions when he needs to. And the last one, we'll go ahead and turn this on, is the organized shutdown or blast session end. I didn't put a tag on it because I don't really know what to name it. None of the machines that we have utilize this particular function. I thought it would be kind of handy. Maybe it was just a waste of my time. Okay, everything's on, so I hit this. It automatically shut the motors off. Recycle will go off. Bada bing. Now, let's say we have it on and everything's on, and we want to do an orderly shutdown. We do the orderly shutdown, wheels kick off, we're like, oh no, something sounds wrong. We can hit that stop even though we're in that orderly shutdown cycle. Everything's pretty well. All the rungs, I don't know if you'll be able to see them or not. All the rungs like this air handler on. That right there, that is the all stop button. Okay, stop it all right now, and that's after a three-way OR, where the switch can turn it on. There's the seal in from that particular output, and then there is a bit from an internal control relay that my drum acts on. My drum acts on internal control relays. It doesn't act on outputs. The reason is because you'll get syntax problems if you try to name an output coil, a real physical output, more than once in the program. It doesn't like it. You could probably get away with it. It's not an error. I think it's just a warning, because don't forget, the last thing that gets scanned, if you have multiple outputs, if you have multiple rungs with the same output, the last thing to get scanned is the one that will be true, not really what the logic says. So drums are better done with internal control relays as what they turn on, and then use contact bits off of those to mess around later on and get the air handler. So there's our stop button, and it's wired normally closed, so it's made through here, and then here's a true if off. That is our organized stop. Okay, so our organized stop is getting a true if off until a timer kicks on. Then when a timer kicks on, it sets that T3 to be true, and it will open that up. But even if it's timing out and waiting on it to open up, you'll still notice that that C2, which is tied to my see right here, that input is the stop button, and it is tied to C2 out. So that is the stop, and it will happen regardless of anything else that's going on in the system. That's always kind of the first and condition in these rungs after my OR logic on what I'm using, either a drum or a timer to turn it on. Kind of weird. I may not be explaining it that well, but it works. I'm pretty excited about it. It was easy. We're on to more stuff. So keep checking this out. I want to make a bunch of these. I'd like to get with other people that are playing with these clicks. All this is done with this little thing, you know. I mean, it's you know, it's half the size of a NEMA 2 motor starter. You know, it's small. It's really small, very small. So it's got a lot of power. I don't know how many timers you could say that we utilized here, you know, for on and off. You know, best case scenario, you could have played with a lot of wiring and some ice cube relays and done it with, I guess, five or six timers, 5 probably. But you know, and then maybe 15-20 bucks a pop for ice cube relays and their sockets. You just have an unlimited amount of flexibility with these PLCs, and the cost is, I paid $109 for mine, 30 or 40 bucks for the control cable. Input and output modules are less than $100, usually 40 to 50. Analog is somewhere around 100. It's really the way to go. You know, you don't want to stay with this old control when you can just clean things up, tidy things up, and the programming is super easy. Like I said, I've never taken any classes for this.